So now that we learned about growth and decay, and we learned about the graphs of growth and decay, we're going to take a little venture into what does that B really mean. And the reason that this is important is exponential functions are really in the real world quite often. Science, economics, statistics, even in calculus. So I really want to take a little adventure into what is B. Well, B is known as the growth factor or the multiplier. And the thing that we call in Algebra 2, we call it the stretch or the compression or the reflection is actually the initial value. That's why it changes it there. But what changes it more dramatically is the B. The B has a much greater effect. And typically, your input in the real world would be time or something like that. So here's the thing. What would it mean in the real world? Again, if we had something like this problem, maybe it's talking about population, maybe it's talking about principal or something. And so this 4 represents how much we started with, but the 1.04 from the previous learning means that it's growth. But the question is, how much growth is it? In Algebra 2, you might just see a number here like 2, right? But what does it mean to have a number like this? Well, this is clearly growth because of the fact that it's above 1. And the growth rate is found by simply realizing that all problems in the real world are based off a 1, 1 meaning 100%, 100% of the people, 100% of the money, 100% of the whatever you're looking at. So if this were a temperature, you're talking about starting at 4. That's what the 1 means. So the 0.04 is the rate that is above that. So it's 0.04 above the 4. Basically, it's going to grow by that amount. And as a percentage, if you remember how percentages work from middle school math or pre-algebra, the rate has to be multiplied by 100%. So my percentage would be a 4% increase over time. And I know that that's a lot of different things, but it's just really important for students in Algebra 2 to realize that you're taking Algebra 2 to be able to move beyond in science and other things. And this is one of the most important things you'll ever learn in a math class, whether or not this chapter is incredibly important. So here, again, the 25 is just the initial value. What I'm seeing here is I'm clearly seeing decay, right? Because it's below 1. Right? That's what that whole 0 less than absolute value of B less than 1 thing meant. B is between 0 and 1, right? So now the question is, well, what is the rate? And remember, this thing can never be negative. That's why we have to focus on, is it bigger or smaller than 1? The B value cannot be a negative number. So the rate, again, in this case, is 0.04, but it's 0.04 because it's that much smaller than 1, right? So if I take 1 and I subtract 0.96, I get that it is 0.04, right? And so if I multiply that by 100, I'm realizing that I'm getting a 4% decay rate. Now, you don't want to put a negative there. I mean, you could, I guess, but really the word decay means negative. So if you put a negative here, you're actually saying that it's growing because the negative and the decay would cancel. Just keep that in mind. So let's take a look at 2 more. The growth ones are fairly easy for students to see. Your brain can automatically look at this and say, oh, that's 0.12. So that's a 12% growth rate. I think where people really have trouble is, again, this is growth. I think where people really have trouble is here. Like, what is that? So it's smaller than 1, so let's agree that it's decay, right? But how much decay is it? Well, if you take 1 and you subtract 0.65 there, you would get 0.35. And so that's a way to find that rate if you can't do it, mentally. And so if you multiply it by 100, you're seeing that you're getting a 35% decay rate. So if you would rather, again, you've already said it's decay here, but I mean, maybe we just go ahead and say this is growth here. Maybe that makes more sense to say the word growth and decay at the percent. It doesn't matter as long as you're identifying it and understanding its growth versus decay. All right, so what do we do now? I know that it's kind of weird to think that this number is positive when you subtract it, and I get that, but we can clearly see that it's decay here. And so maybe that kind of aligns all these things to make sense in terms of them all being positive. but they're clearly being subtracted from 1. I guess a better way to describe it is, because some kids will say, that's a positive number, I don't understand. This is the number that you subtracted from 1 to get the answer that you see here. So it's decay, so we know that we would subtract it, but the actual value of the rate is typically written as a positive number with the label of decay. All right, so let's see more of that in action here. So notice all these things are positive. Some say decay, some say growth. And so what we're going to do is, this one's growth, so we're going to take 1 and we're going to add the 5% as a rate. So we would take 5%, divide by 100% from your middle school or pre-algebra class, and that's the number we're going to add right here to see what B would be. So B, if it says growth, we put an addition sign, and so that'll come out to 1.05. And if it's decay, notice this is the same problem, but it's decay, so this would be, B would be 1 minus 0.05, so B would be 0.95. So maybe that explains a little bit better why up here we had everything being positive numbers, because if the answer is negative, and then I say it's decay, then you would subtract based on the original equation, because subtraction means decay. And so if you subtract a negative, then you'd get a positive. So keep everything as a absolute valued version, meaning whatever you have, write it down as a positive number, but then indicate what you want to do with it by saying decay or growth. So this one, again, this one right here, to figure out what was going on, I have to turn everything into a rate. And maybe you weren't taught this, or maybe you didn't understand it in middle school math, but percentages aren't something you can do math with. They have to be turned into rates in order to have any mathematical computations. So that's why we're doing that. And that's something that a lot of students don't quite understand when they're doing percentages in middle school. So a percent is an idea that has to be converted into a rate. This rate can then be used to do mathematical computations. B is 1 minus the rate, so 1 minus 0.009 is 0.91, and that's the thing that would go in parentheses and indicate that it was decay in the problem. All right, let's do a couple more. So this growth rate is 95%. So 95% divided by 100% would be 0.95. So the growth rate would be, B would be 1 plus 0.95. So B would be 1.95. Now, that's a great problem, because you probably have seen problems just on the previous conversation that had a 2 here. And 2 means to double. But as a percent, you can kind of see here, it means 100% growth. If you ever see a 2, that's what it means. Doubling something is the same thing as 100% growth. It's interesting. That's why I have that problem there. So this one, again, just doing the math here, 0.11%, I'm sorry, 11% would become 0.11 as a rate. Jumped ahead of myself a little bit there, but I got it now. And so the rate, the B, would be 1 minus the rate. So B would be 1 minus 0.11. So B would be 0.89. Okay, and then our last one is 65% decay. So that's a big decay. And so 65% decay would have a rate value of 0.65. And the actual decay rate, the actual B value would be 1 minus this value. So the B would be 0.35. Okay, so just a really important way to understand the world around you. Again, this will come up routinely in physics, even in higher level biology classes. It comes up in economics. It's in calculus. It's the basis of statistics. So I know it's a little bit more, but I think it's very valuable to you.